How are you, everybody who is watching this fantastic video? And also, how are you, some local engineering students that I have in this class? Firstly, I'm very happy to have you today. And thank you for accepting my greeting. I would like just to take a few minutes just to introduce you about what you are going to do and why are we doing so. So, I would like, the first thing which I would like actually to appreciate, I would like to take this opportunity to welcome all the local engineering students who are pursuing ordinary diploma in electronics and telecommunication engineering at DIT, and also others who are pursuing a bachelor degree in electronics and telecommunication engineering at Dar es Salaam Institute of Technology. So today I have those local students, and also in addition to you who is online, we are going to have a very important time. So to appreciate them, let me greet them. How are you, student? How are you, student? So you hear the voice of the boys and or gentlemen and ladies who love electronics. And also, I would like to take this opportunity to welcome invisible or non-physical students who are actually, we call them online students, into this program. We are very happy to have you today, and I'd like to ask you that actually you have to pay focus and you have to be serious because you are going to deliver materials which are very important. My name is Olenjolai. I am a Tanzanian, and by God's grace, I thank God that I'm teaching the beauty of electronics and telecommunication engineering. And teaching for me, actually, it's a work of my heart, and I have to do it for the rest of my life. So I think that I have something to teach you, so you have to stay tuned and stay connected. Another thing which I want to just alert you, these programs is serious. So make sure that you have an exercise book to take a note, and also make sure that you have a pen and a pencil to draw, because we'll be dealing with different concepts. And actually remember that engineering is all about drawings. Another thing that which I want to let you know, this is actual one of the workshops that we are going through. We have covered some workshop previously. You can access in our official YouTube channel, and also you can access our future contents. One thing which I want to remind you, it's very simple to get registered in our online institutions or Polytechnic institutes. We have two online institutions. The first one, we call it Online Bachelor Polytechnics of Tanzania, in square bracket Olenjolai. And the second one, we call it Online Diploma Polytechnics of Tanzania, in square bracket Olenjolai. In order for you to register into those two polytechnics or institutions, you have just to press the buttons of subscribe in the video that you are watching right now, in order for you to receive notification whenever we update or we upload or we add a new video. So if that's the case, now this is the time to learn the beauty of electronics engineering. I know that you love electronics. Let us go into the business. So today we are covering the course or the modules that we call it Fundamental of Practical Electronics. So let me just Fundamental of Practical Electronics Engineering. So let me add some few words. When you say practical electronics, it does not mean that we ignore all these modules does not fit for the computer students. Now, these modules will fit also for them, because our computer engineering is all about the hardware and software, and the hardware is all about electronics. So the modules of the course is called the Fundamental of Practical Electronics Engineering. Fundamental of Practical Electronics Engineering. Fundamental, say with me, Fundamental of Practical Electronics Engineering. Students are sleeping and are not talking. Speak it loudly. Say Fundamental of Practical Electronics Engineering. So we just use the words electronics engineering. Why? Because electronics engineering is the mother of other fields. Electronics engineering is the mother of the hardware computer. Electronics engineering is the mother of the biomedical equipments. And also electronics engineering is the mother of telecommunication engineering. And electronics engineering is the mother of the communication engineering. So when you cover electronics, actually these are the fundamental skills that you might need if you are doing diploma in other courses relating to OT, related to electronics engineering. So today we are going to start chapter 4, which is called Resistor, because you have to cover almost about 10 chapters in this course. It's called Resistor. So class A, Resistor. Say resistor. This is very important to electrical and electronics passive component. So, but before we get into today's topic, let me do the quick review about what we have covered in previous workshop. Okay, so I think that let me mention, so this will be workshop 1 in related to chapter 4. So workshop 1 in related chapter 4, or just you can say workshop 4.1. It means 4 stands for the chapter and 1, this is the workshop 1. So simply you say that this also workshop we just call the name of the chapter. Introduction. So I'm going to introduce to you. So we are going to cover introduction of resistor with regards of what? Of engineering. So regards of engineering, not with science, or with regards of science. So let me do the quick review of what we have covered in previous workshop. So the quick review, if you do remember that, the previous chapter, which was actually chapter 3, so chapter 3, it has been titled as what? As measuring electronics, measuring, and the testing, electronics measuring and testing what? Instrument. So electronics measuring and testing instrument. So in this topic, we have discussed about measuring instrument, and we discussed them, measuring what? Instruments, and we have a number of measuring instruments. For instance, we have DC, we have DC what? We have DC voltmeter, if you do remember. And also you have what? AC voltmeter. And also you have what? Frequency meter, present by this one. Also you have what? Capacitance meter. Also you have what? We have an ammeter. You can have either DC or AC ammeter. So if it is AC ammeter, should have a sinusoid like this. So all of these one are the measuring instrument. And the definition of measuring instruments, you say that these are the electronics instruments which are measuring, or which are responsible to measure the magnitude of electrical quantity. For instance, DC ammeter measures the magnitude of DC current flowing through the circuit or the system. Okay? So that is all about measuring instrument. But again, we discussed with you, I talked about testing instruments. So it's testing instrument, but before testing instrument, if you do remember another concept which I taught you, very important, I talked about symbols of what? Of measuring. Symbols of measuring instrument. Symbols of measuring what? Instrument. So when you talk about symbols of measuring instruments, most of the measuring instruments, they have a symbol and also they have a sign of the waveform or the nature of the waveform, right? So for instance, the symbol for the DC voltmeter, this is the symbol for the DC voltmeter, right? Then the symbol for the AC voltmeter is this one. This is the symbol for the DC voltmeter. For the AC voltmeter. Also the symbol for the DC and the AC voltmeter is just like this one. So this is DC and the AC voltmeter. Are we together? Also the symbol for the ohmmeter is this one. Are we together? But we say that all of these measuring instruments nowadays have been integrated in a wonderful instrument or equipment instrument which we call the digital multimeter. So a digital multimeter, we say that it collects more than one, or it contains actually that it has built-in measuring instruments more than one. So, and also we discussed about 6 digital multimeters, right? So you have to refer, or you have to recall. Then we moved to another subtopic called the testing electronics testing instruments. Electronics testing instrument. And here we say that we have 3. The first one we call it continuity tester or continuity check. The second one we call it diode tester. The other ones we call it transistor tester. Are we together? And then I taught you about what? I taught you about symbols. Symbols of what? Of testing. Symbols of testing what? Instrument. Right? The symbol for the continuity tester is this one. This is the international symbol of the continuity tester. Whenever you see this symbol, the dictum altimeter, that's indicated this continuity tester, or we call it check. Are we together? And then the symbol for the diode tester, this is the symbol for the what? For the diode tester. Are we together? Are we together? Then you have the symbol for what? For the transistor tester. The symbol for the transistor tester is hybrid forward what? Emit. Are we together? But also we have a transistor part or transistor part where that we have to check the terminals of the transistor. Then once I've talked to you about testing instrument and a special continuity tester, then I took you to another subtopic of what, which you call the analysis of what? Analysis of electronics what? Electronic circuit on what? PCB board. Are we together? So analysis of electronic circuits on the PCB board is the subtopic of what? Measuring and testing instrument. And I told you that you are the new brand. I have never taught that concept. Are we together? So in analysis of electronic circuits on the PCB board, we use the continuity tester. Continuity tester, or we call it continuity check, to check the connection between one component to another component. But you use the skills of electronics drawing, right? About the electronic symbols, about the numberings of the different of the same or similar electronics components. So we use different concepts to come up with the schematic circuit diagrams and to reverse the gear. So with this concept, I told you that in electronics, you can analyze a circuit from the PCB board up to the problem statement. Are we together? And I want to tell you that my physical students enjoyed this business more than what they think. Are we together? Are we together? So that's all about what we have covered in previous workshops. So today, we are going to start a new concept that's called the resistor. Say resistor. Say resistor. And ask your neighbor, are you going to call your firstborn resistor? Remember that the motto, this is our motto. This is my motto. My motto in electronics. My motto is called the mind and the what? And the hand. So mind has to work and hand has to build what the mind has understood. So this workshop 1 is will be dealing with what? Mind. Then workshop 2 will be dealing with what? Mind again. And possible workshop 3 and 4 will be dealing with mind and what? And hand. Are we together? So if that's the case, we have a vocabulary here. We have a vocabulary here. That this vocabulary is called the resistor. So let us deal with the first vocabulary or terminology, and the first terminology is resistor. This is not a new terminology in our life. You met it in science, whether in physics, especially in physics. The fundamental question which you have before we learn two details about resistors. Let us first of all ask yourself, what is a resistor? What is a resistor? Before we learn about functions of resistor, types of resistor, what the meaning of resistor itself? Right? I told you that whenever you want to learn anything, you have to know the fundamental, you have to cover the fundamental before other concept. So what is resistor? Class A resistor again. Okay, so for online students, you can pause the video and then try to ask yourself this question. What is resistor? For the physical students, you can take a few seconds just to ask yourself, what is resistor? Once you get an idea, try to write down about what you are thinking about resistor, and then we do correction. Do it now. Do you know meaning of resistor? Try to think, what is the resistor? Resistor is the mango. Resistor is the chair. Resistor is animal. What's the resistor? So pause the video for a few seconds, start at 1 minute, and ask yourself what the meaning of resistor. Why? Because if you ask yourself, then you can analyze if you know the meaning of resistor or you don't know. So when I give you the correct definition, you will absorb it and keep it in your mind. Because you realize yourself that you have nothing about what? Resistor. You just know resistor as resistor. But what is the resistor? You have never asked yourself. Have you finished? Have you finished to try to define? Okay, so I assume that you have finished. So there's a different way that you can define resistor. But let me just give you two ways that you can define the word resistor. Say resistor again. A resistor is a passive. Is a passive to terminal. Is a passive to terminal. Is a passive to terminal electrical or electronics component that implement electrical resistance as a circuit element. So whenever you learn about something and you met with its definition, you should not claim or remember or memorize every term or every word. The simplest way of learning, try to find the keywords. And then the rest of the words will be coming from your brain. Are we together? So the important keyword for this definition, you say a resistor is a passive two-terminal electrical or electronics component. Say passive. In electronics and electrical, we have passive components and the active components. So this actual indicate to you that a resistor is a passive component. But also in electronics and electrical, we have electronics or electrical components which have two terminals, either they have 3 terminals, either they have 4 terminals, either they have 5 terminals, either they have 20 terminals, either they have 100 terminals. But for the case of resistor, from this definition, actual that it gives us information that any resistor should have 2 terminals. 2 what? However, that latons will encounter potentiometer, which it seems like it has 3 terminals. But one terminal is actually an adjustment terminal. So for instance, if for instance a potentiometer it has 3 terminals, right? But actually the resistance or the resistor is either between this terminal and this one, or this one and this one. So even a potentiometer, it is 2 terminals. Have you understood? Listen, for the potentiometer, there are 3 terminals, the way it is. These are the fixed terminals and these are the adjustable terminal, right? Where you can increase resistance and reduce resistance. But if you want to measure the resistance of potentiometer, you have to measure between adjustable terminal and the terminal number 1, or adjustable terminal and terminal number 2, right? So actually resistor is between here and here. Are we together? So even a potentiometer still 2 terminal what? Resistor. Very important, because for me, when I heard this definition, I learned this definition, then a question comes in my mind. How comes that the interpreter or the persons who are actually defining the meaning of resistor state that a resistor has 2 terminals, right? And then I try my level best to read and understand about the resistor, which it seems it has 3 terminals. Are we together? So any resistance should have how many terminals? Unless it's actual a collection. We have some resistors, we call it a resistor pack. Say resistor pack. Say resistor pack. Resistor pack is actually, it's a component, but within it has different resistors arranged within it of the different values. We'll learn it in advanced, okay, of practical electronics engineering. Are we together? Are we together? But simply for this moment, just understand that any resistor, it has 2 until we update your mind, because this is still fundamental. Are we together, class? So this is one way that we can define resistor. So it's a passive 2-terminal electrical electronics component that implements, say implements, say implement, say implement. Add an S here, I forgot. That implements electrical resistance as a circuit element. So this is the component that implements what? Electrical. So we have another vocabulary, and that vocabulary is called what? Resistance. So the next terminology will define what the means of resistance is. Are we together? So it means that this one, these passive components implements what? Electricity. It don't say that it limits current, because I know that what's the resistor? The electrical components that limit what? So today I will brainwash your mind that that's not a correct definition of what? Resistor. But limiting the current, it's only one function of the resistor among 9 functions of the resistor. Wow. Good news. Tell your neighbor, Olenjolai is at work. Okay. So in other words, we can define resistor in this way. A resistor is a passive electrical component. Is a passive electrical component that creates resistance. That creates resistance in the flow. In the flow of what? In the flow of electric current. In the flow of electric current. This is the meaning of what? Of resistance. So a resistor is a passive electrical component that creates what? Resistance in the flow of electrical current. Are we together? So what does it mean? That terminology or new vocabulary, which is called resistance, is being created whenever we have a flow of current passing through what? A resistor. Are we together? So each definition gives you some important information about resistor. Its add value. Okay? Because the first one, it not mention anything about flow of what? Current. Are we together? But actually what we have, the similarity, just implement what? Electrical resistance. You see the first definition mentioned the number of terminals of resistor. But the second definition did not mention the number of terminals. So that's why that whenever you want to learn a new terminology in your life, you have to make sure that you learn from different sources together, different information. Are we together? Is there any question about the meanings of resistor? No, it is still clear. Okay, so those two definitions actual can take you from one point to another point. Then let me give you some examples of resistor before we go to the next terminology. Examples of resistor. So examples of resistors, we have something we call it in, we have carbon examples of resistance in general. Example of resistors are, the first one, we have film carbon resistor. You will see them, film carbon resistor. Then the second one, we have also another one which we call the carbon film. Sorry, this is carbon film. Carbon is called the carbon film resistor. Carbon film resistor. Also we have metal film resistor. And then also we have another example which we call it in photoresistor. Say photoresistor. Or in other words, we call the LDR. LDR is light dependent resistor. Then the fourth example of resistor, we have also surface mount device resistor, surface mounting device resistance, or we call it SMD resistor. But also we have potentiometer. Potentiometer is an example for resistor. We have potentiometer, but also we have resistor that we call it trimmer. Say trimmer. Say trimmer. But also we have a resistor that we call the semester. Semester. So these are the 7 examples of what? Of resistor. 7 examples of resistor. 7 examples of resistor. Seven examples of what? Of resistor. Then, with these examples, once we go through these 7 examples, you get some information. There are another resistor called light dependent resistor. The other one is called semester. So those are the kind of the information that's still giving you some questions, right? What does it mean? And so and so. That's why I ask you to stay connected. So we are done with the first terminology. We are going for the second terminology, and this second terminology is the subset of definition of resistor. And that subset or that terminology is called resistance. Say resistance. Remember that we are learning this material with regards of electronics engineering. Resistance. Say resistance. Say resistance. I want to tell you that, listen, stop writing. I want to tell you, my dear student, if somebody asks you that, which word is, or which terminology is most important compared to the other one, between resistor and the resistance? The answer is resistance. Say resistance. Because resistance, actually, is a very important terminology in electronics. Most of electronics and communication sensors, and most of electronics and communications modules, and most of electronics and communication parts, they use the property of resistance to convey a real world phenomena or a real world physical quantity into electrical physical quantity. That's the introduction, so just a clue in your mind. Okay? So the question is this one. Question number 2. What is resistance? What is resistance? What is resistance? Class, say resistance. Say resistance. Say resistance. Say resistance. So resistance, you can define in more than one way, but I just found one way. You may go and find the other definition or the other ways of defining resistance from other reference. Resistance is a property. Resistance is what? Property. Say property. So resistance is a property of a substance which opposes the flow of electric current. The flow of electric current. So resistance, say resistance. What is the resistance? Resistance is what? is a property. A property of what? Of a substance. That what? Which opposes what? So, any substance that can oppose the flow of current, we say that substance has resistance. It might not be a resistor. Are we together? This is the one point to note. I think that let me write this one. Note. The property of resistance is not only found within the resistor, but it can be found in other substances rather than resistor. This sentence will remind you that. Remember that a resistor, any resistor has resistance, right? But does not mean that resistance is always found only in what? In resistor, but can be found in other what? Material. Are we together? Are we together? Are we together? For instance, are you a resistor or you're not a resistor? Can we call you a resistor or you're not a resistor? Who are you? You're a human being, right? Either a gentleman or what? A lady. Okay? So is your name called the resistor? No. Can you resist the flow of electric current? Can you oppose? You cannot oppose. If you cannot oppose the flow of electric current, we can take two wires now and connect to the socket and they pass through you. Because this is practical electronics. Are you ready? So if you can resist the flow, you can oppose the flow of current, it means that you are a human being, but you have a property of what? Resistance. But you are not what? You are not what? Are you a resistor? Ask your neighbor, are you a resistor? Your neighbor now, because he or she understood, will say a big no. But before, could say, yeah, yes. I am a resistor, I can oppose the flow of what? Okay. Do you have any question about resistance? Okay. If there's any question about resistance, let us go now into details. Let us come back to the terminology of resistor. And this is number 3. Now, let me teach you about types of what? Of resistor. Types of who? Resistor. Say types of resistor. Say types of resistor.
Types of resistor.
So generally, resistors are available in different size, shapes, and what? Different size, shapes, and materials. Shapes and what? And the materials. So you say resistors are available in different size, shapes, and what? Material. So resistors have different shape, resistors have different size, and resistors are made by different material. So it depends that you are categorizing them based on which parameter. So he say in electronics, and the electrical engineering, we have, or there are, two types of resistors. Two types of resistors. Two types of what? Resistors. And these two types of resistor, namely, the first one, we call it T. Number one, we call it linear resistor. Number two, non-linear resistor. Number one is called what? Linear. Say linear resistor. Say linear resistor. And also the second type is called the non-linear resistor. Say non-linear resistor. I believe that you have never heard these two types of resistor. Usually just see being exposed with resistor, the symbol of resistor, arranging resistor in parallel and series, that's all. This is it. But you've never think about whether we have, what are the types of resistor. You might say that the types of resistor are two. The first one, fixed resistor, and the variable, while it's not true. And we'll correct that mistake today. In this workshop, we corrected that mistake today. So non-linearity resistor. So linear resistor or non-linear resistor. So this we call it workshop or lecture 420. So this we call it workshop or lecture 420.1. It means lecture 1 of chapter 4. So after we have mentioned the two types of resistor, let us discuss, or let me introduce to you the meaning of each type. Okay? Are you ready for that? So let us start with the word, with the type of resistor called the linear resistor. Once we cover it, we might go to the second type. Linear resistor. Class A, linear resistor. I again say linear resistor. When you pronounce it, actually you keep in your mind. Because I know it's a new terminology in your mind. So from this vocabulary, we can have the steady vocabulary or the steady question. What is linear resistor? What is linear resistor? What's the meaning of linear resistor? So he said that a linear resistor, we say that either electronics or electrical, passive to terminal, passive to terminal component. Component whose electric current is directly proportional to the applied voltage. So in electronics and electrical, we have two types of resistor. Stop writing, listen, and watch. A linear resistor is electronics or electrical passive two-terminal component. We have discussed about passive two-terminal components. We have already discussed in the definitions of resistor. But what the exceptional property or characteristics of this type of resistor, which is linear resistor, right? So a linear resistor is a resistor, is electronics or electrical passive two-terminal component whose electric current, flowing through it, whose electric current flowing through it, I think that I forgot here, flowing through it. So whose electric current flowing through it is directly proportional. Is what? Directly proportional to the applied what? Voltage. That type of resistor we call what? Linear. And that's the meanings of the word linear. Because actually in science, mathematics, and engineering, the word linear means if you have two parameters and we say that these two parameters are linear. So for instance, in case of the XY axis. So if X increases, also Y increases, right? If X decreases, Y also what? That the means of what? Of linear. It means that one parameter, when one parameter changes, it also changes the another parameter. So when one parameter increases, also it causes the another parameter to increase. When one parameter decreases, also cause another parameter to what? To decrease. Are we together, students? Yes. So simply we say that mathematically you can define, you can just write the formula because engineering is all about what? Numbers, formula and equation, diagrams, then tables and the graph. So mathematically we say that a linear resistor, it's a resistor in which electric current, this will actually remind you, which is I, we use capital I, is very proportional to the applied voltage. To the applied voltage across that linear resistor. So applied voltage, we use V. So simply we say that electric current is there proportional to voltage. Right? According to your knowledge of electrical science, when current is very proportional to the voltage, what does it mean? That is all about what? Ohm's law. State Ohm's law. Ohm's law state that, you forgot? State Ohm's law. Ohm's law said that what? The applied voltage. The applied voltage between 2 points is directly proportional to the electric current flowing through under the condition that temperature and other physical quantities have been kept constant. So voltage is very proportional to current. It means current is also very proportional to but remember that current is being caused by voltage. So this mathematical equation you might write in this way, or you might write in this way, that voltage is very proportional to electric current. Are we together? Are we together? So it means that this equation, it means that V is proportional to this one. This indicates what? V is proportional to voltage. Voltage is proportional to voltage. We say that indicates what? So this mathematical equation, we say that this it is what? It is Ohm's equation. Okay? Where that we can actually simplify and remove proportionality sign and put constant K times I. But K is what? Resistance. So K is equal to R. So you say voltage is equal to current times what? Resistance. So this is our mathematical equation of a linear resistor. So remember that these mathematical equations are very important in designing electronic simulation software. Because if a resistor can be simulated, it means there's a mathematical equation behind it. I talked to you about that. Are we together? Yes. So if this is the case, we can write a note. We say that all linear resistors obeys what? Ohm's law. That's a very important point. Okay, so we have discussed about the meanings of linear resistor. Did you understand the meanings of linear resistor? Okay, so if you've understood, that is good. Now, the next question that I know you might be asking yourself, what are the examples of those linear resistors? So now, let me mention examples of linear resistor. Examples of linear resistor are the following. So I will give you 2 examples and you'll find the rest. The first one, we call it carbon film resistor. Carbon film what? Resistor. The second one, we call it what? Metal film resistor. Metal film what? Resistor. So those are the 2 examples of what? Of linear resistors. We have a number of linear resistors. I just gave you some examples. Can you add some more examples? The other one is what? The third example, another example of linear resistor is called what? Potentiometer. Say potentiometer. Say potentiometer. So potentiometer is a linear resistor, right? Another example of linear resistor is called the primer resistor. Primer what? Resistor. Another example of linear resistor is called the rheostat. During your advanced secondary education, you have learned about rheostat. Whether theoretically or whether what? Practically. Say rheostat. Say rheostat. Say rheostat. Another example is called the wire wound resistor. So a resistor which has been made by using a wire wound is also a linear resistor. It's an example of linear resistor. The 7th example of linear resistor is called what? Carbon composition. Carbon composition resistor. Carbon composition what? Resistor. So in this course or module, we'll be discussing about linear resistor. But before we discuss or we go into details about linear resistor, let me introduce you to you about non-linear resistor. What does it mean and what are the examples? And then from there, we skip non-linear resistor. We'll discuss in advanced practical electronics engineering. But for this time, for these programs of fundamental and intermediate, we'll be discussing about linear what? because you have also to know about non-linearity. But non-linear resistor is a little bit advanced compared to the linear resistor. So we got the second type. Second type is what? Non-what? Non-linear. Non-linear resistor. So remember that we are learning this information with regards of engineering. However, that scientists also they can get some information, but not much as engineers. So what do we want to learn about non-linear resistor? We just want to learn three things. The first one, definition. What does it mean? The second one, does it obey Ohm's law or not? Right? And then the third one, or the third concept, what are the examples? So in case that you hear about that resistor, you can notice that this is linear and this is non. Remember that these are the fundamental skills for ordinary diploma students in electronics and telecommunication, ordinary diploma students in computer, ordinary diploma students in biomedical, in electrical field. Question number what? So this gives us question number 4. What is non-linear? What is non-linear resistor? Say non-linear resistor. Say non-linear resistor. So what is non-linear resistor? What does it mean? What the meanings of non-linear resistor? Before you know the examples, whether to obey Ohm's law, what does it mean? Students, my dear students, this is the way I used to learn myself about electronics. I always start from fundamentals. And whenever you find me that I'm learning a new skills, you might find that just like I'm a very crazy because I start with fundamental, which for you might ignore them, right? And the fifth fundamental skills that I always start whenever I learn any new skills, definitions of the terminology first. Are we together? Because almost what I'm teaching you is almost more than 70% I learned myself. Not taught at the college or maybe at the institutions where I was studying. I was not taught at the advanced level or in secondary education. What is non-linear resistor? I've just get fundamental from those places. So a non-linear resistor, a non-linear what? A non-linear resistor is a resistor in which the flow of electric current through it, through it is not directly proportional. Is not directly proportional to the applied voltage. It's not directly proportional to applied voltage. But current changes within it, which is non-linear resistor, with the change. Current changes within it with the due to change of 40 of temperature. Change of 40, change of temperature or applied voltage. No, use the change of 40 of So here is the definition of what? Definitions of nonlinear resistor. Stop writing, listen, and watch. Let me explain the definition. A nonlinear resistor is a resistor in which the flow, say flow, of electric current through it is not directly proportional. It's not directly what? To the what? To the applied what? But that electric current flowing through that circuit or that system changes within that nonlinear resistor due to the change of temperature. Remember that Ohm's law state that, how does it state? Ohm's law state that, Ohm's law state that the applied voltage between the 2 points is directly proportional to the OT, the amount of electric current flowing through the OT, the circuit, under the condition that, or provided that, temperature and other physical quantities are kept constant. So if temperature is not kept constant, that's not about Ohm's law. Right? So for this one, we say when temperature changes, then current changes. Are we together? So does nonlinear resistor obey Ohm's law? Does nonlinear resistor obey Ohm's law? No, simple. I'm trying my level best to teach you this concept in a simple and in the simplest language so that you keep in your mind as electronics engineer or technician, right? These are not the material that you have to review them maybe a year. You're still reviewing about this material. No, you have to understand and keep in your mind. Is this linear resistor? Whenever you find a resistor, you have to ask yourself, is this linear resistor? No. Is it non-linear resistor? No. Good luck, you are good luck. Stand up. So remember that, why do we define this terminology in terms of the dependence of the two parameters? Remember that in science and engineering, we always deduce mathematical equation if you have 2 or 3 parameters that vary. Are we together? For instance, Ohms deduced the Ohm's equation when he observed the change of voltage with respect to what? Change of what? Current. So remember that if you find something, the change of the two parameters is not directly proportional, don't say that just the variations is inversely proportional. It might be another mathematical equation. So according to this definition, we don't know yet the mathematical equation that shows relationship between current flowing through the non-linear resistor with the change of what? Temperature. So that is not the case for this time. Are we together? But simply say that what? Ask your neighbor, are you going to call your second one non-linear resistor? So non-linear resistor, Olenjolai. Non-linear resistor, Farid. Non-linear resistors, this obey. Disobey what? Ohms. Ohms what? Ohm's law. This is the second concept that you have to learn. The next and the last concept that you have to learn about the non-linear resistor is examples of what? Of non-linear resistor. Let me mention examples of non-linear resistor. So examples of non-linear resistors are the first one is called the what? The first one is this one. The first one is called the photoresistor. Photoresistor, or we call it light dependent resistor. In short, we used to call it LDR. L stands for light, D stands for dependent, and V and R stands for what? Resistor. So the first example, say photoresistor. Say photoresistor. Say photoresistor. Again, photoresistor. Say light dependent resistor. Light dependent resistor. Remember that when you pronounce, you are keeping, you are writing your what? In your mind. So this is the resistor in which the resistance vary with the variations of what? Rays of light. The word photo means what? Light. So the resistance of photoresistor depends on the amount of what? Light falling on it. And we are going to deal with this one in future. Are we together? Are we together? So it means the variations of resistance or the variations of current will be caused by what? Light, not voltage. Are we together? The second example is called the semester. Say semester. Say semester. What is semester? So semester, we say that this is the word made by two words, semi and star. These are the two words, semi and then I and S. This is another way. Yaki, we are moving. Semi star. So semester is a combination of the two words. The word semi, this means semo. This means what? Let me just give you a brief, because I know for most of you this is the new terminology. This means what? Thermo. You know the meanings of semo? For instance, you say thermometer. Say thermo. Thermo means what? It's all about what? Temperature. Because when you say temperature, it's actual. What is temperature? Temperature is a degree of hotness or what? Coldness. And then the word Easter. This comes from the word resistor. So these are the words which have been taken. Right? And for the word of semo, just we call it semo. So you see that these are the words which have been taken. Semo is an actual abbreviation of semometry. So you can have a word semometry. Semometry. Are we together? So this is the nonlinear resistor in which the resistance change with the change of temperature. Right? And during test 1 of electron sporadic fabrications and electron drawing, possibly have written it as what? As a sensor which will measure what? Temperature within W what? 15 for those days. Then the second one is called the varistor. Say varistor. Say varistor. Say varistor. Say varistor. Say varistor. So varistor what? Resistor. So varistor resistor, let me leave you as a challenge. Go and read what it means of varistor resistor. Then the fourth one, it's a component which I've already introduced it to you. And this one, it has a very interesting name. Surface, ladies and gentlemen, surface what? Mount device. In short is what? SMD. SMD what? Non-linear resistor. So surface mounting device, it's a non-linear. So in most of modern PCB boards, we have what? In most of modern PCB boards, we have what? We have non-linear resistor. We have non-linear what? Resistor. So these are the very important 4 examples of what? Non-linear resistor. Let me know if there are any questions about what I've taught you about non-linear resistor up to this time. If you have, raise up your hand. For the online community, in case you have any question, don't hesitate, write in the chat when this video going live. or don't hesitate to ask that questions in the comment sections below the video that you are watching. If this is the first time to meet us, you are warmly welcome. We are here to change the world. We are here to change our beautiful nation called Tanzania. So for you to be a part of, just register yourself by subscribing and then stay connected, because you should always be online. You may subscribe, but when you be offline, we have no way out that to reach you. Whether in Tanzania, Uganda, Kenya, you can benefit from this material. Class, are we together? So I believe that up to this point, you have some information about what, about T, non and the linear resistor, and actually I know that it's a new information in your mind, isn't it? Are we together? Okay, so if there's no any question, now, so we have learned types of what? We've learned about what? Linear and non-linear resistor. Okay? We have learned about what? Linear and non-linear what? Resistor. So, let us go. In this module, we are going to cover about linear resistor. So, we have to go back to the linear resistor and then dig in detail. All the remaining lectures or workshop will be all about what? Linear what? Resistor. So, we'll cover non-linear resistor where? In advanced practical electronics what? Engineering. So, stay connected. Have your seat. Good luck. Are you ready to continue? Class, are you ready? Okay. So let us go back to number 1, because you say there's no any question. Let us go back about linear resistor. What I've introduced to you about non-linear resistor is enough. The first concept, the fourth concept that you have to learn about linear resistor is we have to ask ourselves a question. Do we have types of linear resistor? Ask yourself that question. According to what you know, do you have types of linear resistor? Once you finish, ask your neighbor, because I know you like to ask your neighbor more than asking yourself. What did he or she say? We have. How many types do you have? That's another challenge. How many types? If you have types of linear resistor, how many types do you have? 2. 2 types of linear resistor. Good. I mentioned them. Variable. So we have fixed linear resistor and variable linear resistor. Very good. Clap your hand for him. So let us. So 1, 2, 3. Hongera. Imara. Wow. So for English people, they hear our Swahili, right? So your answer is correct. Types of 40 of linear resistor. Types of linear resistor. So he said that in electrical and the electronics engineering, in electrical and the electronics engineering, there are 2 types of linear resistor. 2 types of linear resistor, and these types of linear resistor, namely as the first type is called fixed fixed linear resistor, fixed linear resistor, and the second type is called the variable linear resistor. Fixed linear resistor, and the second type is called the variable linear resistor. The first one is called what? Fixed linear resistor. The second one is called what? Variable linear resistor. So when you be asked that, mention types of resistor, don't say that fixed resistor and linear resistor. No. These are the two types of linear. Types of resistor are what? Linear and the types of linear resistor are what? Fixed and the. So I know many students used to confuse fixed linear resistor and variable linear resistor. So let us discuss about a fixed linear resistor. Fixed linear resistor. Fixed linear resistor. Say fixed linear resistor. Say fixed linear resistor. Here we get to question number 5, fundamental question number 5. What is fixed linear resistor? What is fixed linear resistor? Fixed linear resistor is electrical or electronics component. It's electrical electronics component whose current flowing through it is directly proportional to the applied voltage. Is applied duty direct proportional to the applied duty? To the applied duty voltage, and it has a fixed value of resistance. So writing. When you read the 70% of this definition, you might think that the definition of fixed linear resistor is the same or is similar with the definitions of linear resistor, right? But now the difference is to the last part, to the last sections, to the last statement. So you say this is a electrical electronics components. This is a passive. I forgot here to put the word passive electrical or electronics components whose current flowing through it is directly proportional to the applied voltage, and it has a fixed value of 40. Fixed value of 40 resistor. What does it mean? What the meaning of the word fixed? So he said that once the fixed linear resistor has been made, its resistance cannot change or cannot vary. Are we together? cannot change or cannot vary. But in case of variable resistor, when it has been made, its resistance can vary, but within the specified range by the manufacturer. Are we together? If we have a variable, if you have a fixed resistor of 1 kilo ohm, its resistance will remain with 1 kilo ohm all the time. You don't have any chance to lower the resistance maybe to 500 ohm. You don't have any chance to lower the resistance maybe up to 608 ohm. Are we together? But if you have a variable resistor, Jackie, it's time to listen and watch. If you have variable resistor of 1 kilo ohm, it means its resistance can vary from 0 ohm to 1 kilo ohm or 1000 ohm. So it can vary. So you can actually adjust the resistance up to even 100 ohm. Are we together? Are we together? So the difference between them is just if resistor can vary or resistor is what? Fixed the value. Class, are we together? A? So this is, let me just include as a note. Say, the resistance, the value of resistance of fixed linear resistor, the value of resistance of fixed linear resistor is always constant or fixed. Are we together? Class, are we together? So in this course, we'll be learning about what? About fixed linear resistor. So before we learn about types of fixed linear resistor, let me give you some examples. Examples of fixed linear resistor. The first one, we have carbon composition resistor. The second one, we have wire wound. Wire wound resistor. It's another example of linear or fixed linear resistor. The other one is called the carbon film resistor. Carbon film what? Carbon film The first example, we have metal film resistor. First example of fixed linear resistor, metal film resistor. Later on, you may use the internet. Just so you can check the image. Listen, you may use the internet just to check the image of these resistors that I've taught you today. Are we together? You just go in Google and search carbon composition resistor. You see its image. And it's completely different from the wire wound resistor, right? It's completely different from the carbon film resistor. Because in the next workshop, I will come with some of them. We'll see them physically. Are we together? Okay. Then the fifth example is called the metal oxide resistor. Metal oxide resistor. Metal oxide what? Resistor. Those are the 5 examples, etc., etc., etc. These are the 5 examples of 40 fixed linear resistor. Is it clear? Is there any question? No question. Then let us get in or dig in fixed linear resistor. Then we find another question. What are the types of fixed linear resistor? What are the types of fixed linear resistor? Say types of fixed linear resistor. Do we have types of fixed linear resistor? So the one or the students who have answered that question or the questions of the types of linear resistor, I think that he has never thought about the types of fixed linear resistor. Is it true? Have you ever think about that? No. But the truth. We say that, so it's a new information for you. In electronics and the electrical engineering, there are 2 types of fixed linear resistor. Namely, there are 2 types of fixed linear resistor. The first one, we call it what? Not 3, not 2. There are 4. Good news, which you have never thought, you have never known. In electronics and electrical engineering, we have 4 types of what? Fixed linear what? Resistor. So the first type, we call it carbon composition resistor. Carbon composition, say with me, carbon composition resistor. Again, say carbon composition resistor. So this is the resistor which has been made by using what? Carbon. The second type of fixed linear resistor is called the wire wound. So this is, even the ear shapes is completely different. Wire wound resistor. Wire wound resistor. Say wire wound resistor. Number 3, the third type is called the sick film. Sick film resistor. Say sick film resistor. Say sick film resistor. Sick film resistor. So you have thick film resistor and also you have thin film resistor. So the physical, the size, the shape of these 4 types of fixed linear resistor is different. Are we together? Are we together? This contains what? Carbon. Carbon is what? Is an element, right? Element number what in the periodic table? Number 6, yeah? Then wire wound. Say wire wound resistor. Say wire wound resistor. So wire wound resistor is actually a resistor which has been made by winding the wire around the metal. Then you have thick film resistor. Say thick film resistor. So thick film resistor is thick, and it has a different color coding or different color. And also you have what is thin film resistor. So these are the 4 types of what of fixed linear resistor. I want to tell you that this is still fundamental concepts, because I hear some students say, Olenjolai, now you are taking us to the advanced level. Thick, thin. Why are we learning all of those? So another question, whether online students or these physical students, they're asking themselves a question. Why should we just know resistor and then that's all? We're electronic engineers. We don't think to make a resistor. Yeah, we don't think to make a resistor, but we have a responsibility to learn and use resistor. Are we together? Are we together? Class, are we together? So this is still fundamental concept, and all of these types and all of these resistors are available. You can encounter them whether in a single-sided PCB boards or whether, yes, but I have some example. Oh God, thank you very much. You have reminded me. Here we have something called resistor pack. So resistor pack. So these are the fixed linear resistor. It's one of the type. Fixed linear what? So the resistance of this resistor is 5.1 kilo ohm. So you can take one. And also this is another one. Actually it is a bunch of resistor. This is 2.2 kilo ohm. You can take and have a look. And this one is 10 ara. 10 ara means it is 10 ohm. Batch of 40 of resistor. So you can have a look of them. And also I still have some more. So these are the examples of 40 linear resistor. Say linear resistor. This one, you see the color is blue. Sometimes you can find the color is gray. Right? Don't worry that I'll be using the image to teach you about these different types of 40 of resistor. Are we together? So this is the pack of 10 ohm resistor. And then this one is 5.1 kilo ohm. Just take and give to another student. I want students to see what we are learning. And you have to take care of those resistors so that they may not fall. So for instance, these are the resistors which I ordered from China. Right? So resistors are being sold in this form. So for instance, I ordered a resistor for 4.0 or 47 ohm. So actually it comes. If I order 10 pieces, it comes in that way. So it's resistance being written. This also it is 10 ohm. Take and pass to another student. Now we are going for the part of demonstration which is practical. And this one also, this is another pack. This is 2.2 kilo ohm. And these are the resistors. These are the fixed linear resistor. This is 680 kilo ohm. In the next workshop, I will teach you about what is standard values of 40 resistor. I've just introduced you, but in this course, I'm going to teach you. So tomorrow, I will come with the different types of 40 fixed linear resistor, and you'll enjoy. Because you used to think that you know resistor. But I want to tell you that you don't know the resistor in the satisfactory level. Are we together? Yeah? Ask your neighbor, do you still enjoying electronics engineering? Okay, so then in these 4 types of fixed linear resistor, we still have some types within these types. Don't chat, please. I gave you a task to go and check the images of carbon composition resistor. Check the image of wire wound resistor. Check the image of thick film resistor. But tomorrow I will come with them. With some of them. Are we together? Yes. Remember that learning without seeing, simple for you to forget. And then learning without doing, simple for you to fail to understand at all. So if that's the case, ladies and gentlemen, let us wind up our today's workshop or lecture 1 by learning types of what? Thick film resistor and the thin film resistor. Then from there, I will leave the homework for you, and then we meet in the next lecture, lecture 2 or workshop 2. But I think that you have got good news. So I saw one student raise the hand, or raise his hand. I will give you a chance to ask you the question. Types of thick. Say thick. Ask your neighbor, are you thick film resistor or thin film resistor? Thick. Types of thick film what? Read it. Types of what? I want to tell you that don't expect that you will find many articles or many books which explain resistors in depth like this. You have to read different sources and then gather the knowledge. So he said that in where electronics and what? Ask your neighbor, do you still love electronics, like electronics? Electronics engineering. In electronics and electrical engineering, there are 3 types of thick security film what? Resistor. Namely what? The first one, we call it fusible resistor. Fusible resistor. You may go and check whether fusible resistor relates with fuse. Fusible what? Fusible. We find all of these resistors within the motherboard or any electronics motherboard. Right? Fusible what? And then the other ones is called what? Cement resistor. Cement resistor. Then the third type is called the metal. Say metal. Say metal. Say metal. Metal oxide resistor. Do you remember that in science, in transistor, we have metal oxide field defect transistor, or in short we call it MOS. So also you can use metal oxide. Stop writing. We may use metal oxide to make what? Resistor. Say metal oxide. Say metal oxide. What are the examples of metal oxide? We have calcium oxide. We have lithium oxide. That is chemistry now. We have what? Sodium oxide. And we have what again? Calcium oxide. We have again what? Magnesium oxide. Copper oxide. Zinc oxide. Again? Lead oxide. So you might see that these are the applications of chemistry which you have been learning. Okay? Because you have metal oxide resistor, and also we have metal oxide field effect which is called what? MOSFET. And MOSFET changed the world. And it is still changing the world. Whether you like or you don't. But for you, you say, I am a PCM. You know that, I am a PCM man. I don't like chemistry. Because in PCM we are calculating and dealing with physics. Okay, fine. But when you come to this point, when we talk the chemistry language, you are a stranger, you are a foreigner. You don't understand us. Are we together, class? Then let us come to the last part. Then I will give you a summary. Types of what? Types of who? Seen what? Seen, film, resistor. Say seen, film, resistor. Say seen, film, resistor. Very good. So in electrical and the electronics, engineering, there are two types of seen, film, resistor. Namely, the first one we call it what? Carbon film resistor. Carbon film what? Film resistor. And the second one is called the metal film resistor. Metal film what? Metal film resistor. So those are the two types of what? Of seen film resistor. Hello. Good afternoon. Good afternoon. Okay, so remember that you still have my resistors on the table. And take a photo of them and keep that photo. Commands, you had a question. You're welcome. So which type of that resistor? Okay, I will let you know when I will bring some other different types of resistor. But simply that is carbon composition resistor. So I don't want it to just to give you a straight answer, because you'll ask me the next questions. How did you know that is carbon? So I think that tomorrow when you cover about how we can distinguish them, or in the next workshop, you will know that whenever I see this color or this color for the entire resistor, I'm not talking about color, a color code, right? Then this is the maybe this is the thick film resistor, or this is the thin film resistor. Okay? So stay connected. I will answer that question later on. Are we together? Are we together? Is it clear? Is it clear? Okay, so let us, thank you very much. So Mr. Andrew Kamanzi asked me a question. How did, which type of resistor is that resistor which I showed you as a resistor pack? So the answer is you have to stay connected. We'll learn about how we can distinguish them. So we have covered a number of materials today, isn't it? For the human beings actually to remember all of those informations within a time while you still remember about other things, it might be difficult. Let me give you a summary. Are we together? Let me give you what? A summary. And this summary is actually a summary of what? A summary about resistor. So stop writing. This summary which I'm giving you, you know it. I have taught you. So stop writing. So you have to guide me. Are we together? And I'm going to use the concept which I use to call it whenever I teach this stuff. Big picture. Say big picture. So this is the big picture. What I've taught you, it's a big picture about resistor. And this is the big hidden picture, that which you have never thought about it. Are we together? So in our big picture, the top, we had what? Something we call it what? Resistor. Isn't it? What are the types of resistor? We have two types of what? Of resistor, right? The first one is what? Linear. This summary will help you to remember. Linear what? Resistor. The second one is called what? Non-linear. Now it is simple. Non-linear what? Resistor. Then let us keep focus here, because this is what we have discussed. How many types of linear resistor do we have? Two of them. So let us leave non-linear resistor for a while. So you have two types of linear resistor. Mention them. Jacob. I say stop writing. It's time for someone. Mankina. So it is what the types of linear resistor what? Discrete. Yeah, now you're expert here. Ask your neighbor. Now you're expert here. Now you're expert about what we have covered today. Not about resistor. Fixed linear what? Resistor. And the second type is called what? Variable what? Linear what? Resistor. Right? And then we discussed in detail about fixed linear resistor, right? How many types do you have of fixed linear resistor? 4. And the first one? Pardon? Carbon composition. Carbon composition what? Resistor. The second type? Wire wood. Resistor. The third type? Security. Sick film what? Resistor. The fourth type is what? Thin film resistor. Okay? Did you study? Was I still drawing? Was I? I still writing. Did you learn any types of carbon composition resistor? No. Did you learn any types of wire wound resistor? No. Did you learn any types of thick film resistor? Yes. And for thin film resistor? Yes. How many types of thick film resistor do you have? 3. How many types of thin film resistor do you have? 2. So just finish up, and then we have a summary in our mind. That's why I tell you that there is no need for you to claim in electronics engineering. Why? Because it's simple to localize. Simple to localize what? The concept. Stop writing. Stop drawing. Stop writing. So here we have what? 3 types, and here we have 2 types. Okay? So this is called what? Sick. Sick what? Film what? Resistor. And here we have how many types? 3. Why did I draw on this other side? Because I don't have any more space on this blackboard, right? It's not a concept. For your exercise book, I know that you can draw at the bottoms of this line and this arrow and this arrow. Okay? So the types of thick film resistor are what? Fusible. Does it relate with fusing? Fusible what? Fusible film resistor or fusible resistor. The second type? Pardon? Signing? Pardon? Class. Cement. So you failed to pronounce cement. Cement what? And the other one? You are waiting that. You are waiting me to ask. Metal oxide. So when your young brother or sister asks you about where do we use chemistry in engineering, at least now you have some information, eh? Metal oxide what? Resistor. And that will be good news for the students who hate what? Chemistry, especially what? Organic chemistry. Because most of PCM, they hate what? Organic or inorganic. If you be expert in organic chemistry, you will hate inorganic chemistry. Why? Because there is no mathematics, especially for inorganic. It's just the conversion of what? Breaking and the formulation of what? Chemical bonds. From what? From carbon to what? To polymer. I thank God by His grace also I'm teaching chemistry from Form 1 to Form 6. So I don't know about you. For me, I love chemistry. How many times do you have for the film resistor? Seen film resistor? Mention them. Regulator. Carbon film. Carbon film resistor. Another example, another type. Metal film resistor. So from this summary of linear resistor, you might notice that now it is simple for you to remember. Isn't it? Because many engineering students, they used to believe that if you're an engineer, you should not have a lot of explanation. An engineer actually talk briefly but meaningful. So let me give you a summary of what. Let us go for the nonlinear resistor now. Let us finish this summary and then it will be the end. I will leave the homework, because a teacher who leaves the homework to his or her students, he shows love to them. Okay? So we are going for the summary. So a summary of nonlinear resistor. So on top we have what? Resistor, right? And we have how many types of resistor? 2. The first one is what? Linear. But we have discussed about linear what? Resistor. Our interest now is to have a summary of non-linear what? Non-linear resistor. It's better also to learn engineering, electronics engineering, by using drawings and, summarization. That's very important. How many examples did we mention of non-linear resistor? How many? You forgot? We mentioned the 4 examples. Now it is time to listen and watch. The first one is called what? Emitter. Photo resistor. Photo resistor, or we call light dependent resistor. You are writing again. Then the other one is what? Semester. The other one is called what? Varistor. Varistor what? Semester what? Resistor. Varistor is what? Called the varistor what? Resistor. The other one is called what? Surface mounting, not mounting. Surface mounting device resistor. In short, we call it what? SMD what? Resistor. That's all about what we have discussed. Are we together? Now it's time for what? For homework. So this is homework 4.1. Say homework 4.1. Mention 9 functions of resistor. Why do we need resistor? It means we need a resistor because it performs a particular function within the circuit. And one of the functions that you know is to limit your current. But you don't know other 8 functions of what? Other 8 functions of what? And some of those 8 functions, some of them are applied in telecommunication engineering, especially in wireless communication. So go and find. You should not go and Google. Go and find and read each function. I think that, not mention, explain. Mention and explain. Mention and what? Explain. Briefly. 9 functions of resistor. Because if you just mention, you go and you Google. But even just explain, you go and Google. The problems is not for you to Google. We really advise you to use the internet to learn, right? The problem is, do you understand what you are writing? So once you go for the Google search engine, you have to read, understand. Sometimes you may even read 2 articles or 2 sources. And then you summarize. Are we together? And then you write a brief information which you can explain what does it mean. That's the technique I use. I also use Google. Fatu, I also use what? Google. But I'm not using Google to copy and paste. Mohosa is writing. Yes. Mohosa is what? Right. Class, are we together? Okay, let me give you a chance. If you have any question about what we've covered, ask. If there is no any question, I would like to say that this is the end of workshop 4 or lecture 4.1. Thank you very much for joining me. In case you have any question, don't hesitate to ask in the comment section below. For the local students, you'll have an access of this video just within a short time. The only thing which I really insist you, make sure that you subscribe onto our official YouTube channel that's called the Online Bachelor Polytechnics of Tanzania in square bracket Olenjolai. Also subscribe into our diploma official YouTube channel, which is Polytechnics, which is Online Polytechnics, that's called the Online Diploma Polytechnics of Tanzania in square bracket Olenjolai. So if that's the case, please make sure that you invite some other students and you share the link of this video in order to have a number of electronics and practical electronics engineers in our own beautiful country to solve our real electronics engineering problems that our community and society suffer. That's the main goal and that's the main objective of what I'm doing. I'm trying to share what I know in order to make sure that I equip students or equip lovers of electronics in our country to solve real life problems. Are we together? So make sure that you invite some other students in order to be together and move forward to learn the beauty of electrical engineering or electronics engineering or telecommunication engineering or communication engineering or computer engineering or biomedical engineering. These contents worthy for them. So if that's the case, then I would like to say that thank you. See you in the next workshop, which will be workshop 4.2, where we start with corrections of the homework number 4.1. Thank you very much. See you in the next workshop.